Alright, in a CP level class, you're only expected to be able to write the first and second quantum number. Okay? The first quantum number has a symbol N. The second quantum number has a symbol L. Both these are lowercase letters, and I use the script L because if I just use a line, like a printing an L, lowercase L, you can't tell the difference between that and 1 or a capital I. You know, it's just, some people write their I's and ones the same way. So I always use a script L, and I ask you to use a script L. So quantum number 1, now remember, quantum numbers, or I've related them to like an address, okay? When we're doing electron configurations and orbital rotations, that's like telling how many people live in a whole neighborhood, okay? Whereas quantum numbers tell you the specific address for one single electron, all right? Not for a whole bunch of electrons, but for one single electron. And just to kind of keep it as simple as possible, because I think quantum numbers for chemistry are not as nearly as important as the orbital rotation electron configurations. What I did was to make you relate that to those. So specifically orbital rotation, let's take and pick an element like maybe silicon. And let's write an orbital rotation for it, and then pick one electron from that and write the quantum numbers for that, just to give you an idea of what I've asked you to do in this class. So here's silicon right here. And so what we're going to do is add up all the, write all the orbital rotation for all the electrons leading up to where we are with silicon. So remember, when we're doing orbital rotation electron configurations, helium best belongs right here, because these first two columns represent the S sublevel region. So we're going to do silicon here. And so in the first primary level, this would be row 1. In the first primary level, we have an S sublevel first, and the box is representing the orbital, and so there's only one orbital in an S sublevel. And hydrogen and helium, which belongs here then in this context, will have one electron and a second electron for those two elements. Okay? Then we're down here at lithium. Now lithium is in a second row. Well, that represents a second primary level, but these are the two columns that represent the S sublevel region. So that's 2s. Again, there's only one orbital, that's represented by the box, in an S sublevel. And so lithium has an electron, and beryllium has a second electron. And we use this opposite arrows, one arrow going up, one arrow going down, to show that they have opposite spins. That directly relates to the concept of quantum numbers, and we'll get to in a minute. So now we're going to move over here to where boron is. Well, that's not the S sublevel region anymore. That's the P sublevel region. There are 1, 2, 3, 4, 5, 6 elements in that row in the P sublevel region. And so I'm going to need, since I can only put 2 electrons in an orbital, I need 3 orbitals. So I need, this is still the second primary level, second row. This is the P sublevel region, but I need 3 orbitals. 1, 2, 3 boxes. And using what we call the school bus rule, we put 1 electron in each box. So that's boron, carbon, nitrogen. And then when we get to oxygen, we come back and pair them up. And now we're at neon. Okay? Well, let's see, we got to go one more row because we're trying to get to, well, silicon. And so we're going to be in the third primary level, corresponding to the third row, starting off with the S sublevel region. Fill up those two for sodium and magnesium. And then over here for silicon, this is 3p. You have 3 orbitals. We only need 2 electrons there. Okay, for aluminum and silicon. So we're going to stop right there. Okay? Now what we want to do is to write quantum numbers for just the first 2 quantum numbers for just one of those electrons. We can pick any one of those electrons we want. Okay? I'm going to choose this one right here. Okay? Alright. So the first quantum number, N, tells you what primary energy level that electron is located in. Well, that primary energy level is given to you by that letter 2, right? I mean, that number 2 there. So N equals 2. Okay? L tells you what sublevel region the electron is located in. The sublevels using quantum numbers in orbital notation are represented by S, P, D, or F. But in quantum numbers, L, S will always be 0, P will always be 1, and D will always be 3. F is 4, but we didn't get the F sublevel regions in CP chemistry. Okay? So since this electron is in the P sublevel, L is going to be 1. And so those are the first two quantum numbers for that electron. There are actually two more quantum numbers that we don't deal with in CP chemistry.